By the end of this lesson, you should be able to state the refractive index n as speed of light in vacuum over speed of light in medium. Solve problems involving the refraction of light. Observe the refraction of sunlight through different mediums. What do you see? Does light travel with the same speed in different mediums? Does light travel with the same speed in different mediums? Consider a fast-moving car on hard ground going into a region of soft ground at an angle. The tire that enters the soft ground will slow down while the other tires that are on hard ground are still going fast. As a result of the car going from hard ground to soft ground, the direction of the car changes. The changing path that the car travels between different mediums best describes how light travels with different speed in different mediums. Light travels fastest in vacuum, and its speed decreases when it enters another medium. What is the relationship between the speed of light in vacuum and the speed of light in a medium? The refractive index of a medium is given by n equals to sine I over sine R. The refractive index of medium is also equal to the ratio of speed of light in vacuum or air to the speed of light in a medium. That is, n equals to speed of light in vacuum or air over speed of light in a medium, or n equals c over v. Hence, if the speed of light in water is 2.25 times 10 power of 8 meter per second, and the speed of light in vacuum is 3.00 times 10 power of 8 meters per second, then the refractive index of water is n equals to 3.00 times 10 power of 8 over 2.25 times 10 power of 8 equals to 1.33. Refractive index of glass equals to speed of light in vacuum over speed of light in glass equals to 3.00 times 10 power of 8 over 2.00 times 10 power of 8 equals to 1.50. Similarly, refractive index of diamond equals to 3.00 times 10 power of 8 over 1.24 times 10 power of 8 equals to 2.42. Why does a straight rod appear bent in a liquid? Due to the refraction of light from region below the liquid surface, a straight rod sticking out of a liquid surface appears bent. Similarly, the bottom of the container of liquid appears to be nearer to the surface of the liquid. In other words, the liquid appears to be shallower than it actually is. Refractive index of a medium, n equals to sine I over sine R. For small angle of incidence and small angle of refraction, sine I is approximately equal to tangent I, and sine R is approximately equal to tangent R. Therefore, n is approximately equal to tangent I over tangent R, equals to y over d prime over y over d, equals to d over d prime, equals to real depth over apparent depth. The refractive index n of a medium can be calculated using the formula n equals to real depth over apparent depth. If the real depth of the liquid is 20.0 centimeters and the apparent depth of the liquid is 16.0 centimeters, then the refractive index of that liquid is n equals to 1.25.
An object in water appears to be closer to the surface than its actual distance. This is because light traveling from water to air is refracted away from the normal, and as a result, we see the image to be nearer to the surface of the water. In this activity, you can explore how the fish in the water tank appears to be nearer to the surface of the water. Move the slider to vary the water depth and observe the apparent depth of the fish in the water. Determine the refractive index of water by measuring the real depth and the apparent depth of water in a beaker. Materials needed: a 250 milliliter beaker filled with about 200 milliliters of water, 2 pieces of white cardboard 10 centimeters by 5 centimeters, a half-meter rule, a retort stand with clamp. Procedure: draw a line on both cardboards. Put one cardboard with the line facing up on the tabletop. Put the beaker of water on top of the cardboard. Mount the half-meter rule vertically with the use of the retort stand and the clamp. Looking down into the beaker from above, raise the second cardboard until the two lines appear to coincide with no parallax. Measure the real and apparent depths of the water in the beaker. Calculate the refractive index of water using the formula. Refractive index n equals real depth over apparent depth.